In this example, we're given that y is x squared over the square root of x plus 1. And we want to show that dy dx is equal to x into 3x plus 4 all over 2x plus 1 root x plus 1. We have u equals x squared and v is x plus 1 to the half. That means du dx is equal to 2x. And dv dx is a half x plus 1 to the minus a half times the differential of what's inside, but that's just 1 anyway. We know the quotient rule is that dy dx is v du dx, take away u dv dx, all over v squared. So dy dx is going to be v times du dx, so that's 2x into x plus 1 to the half. Take away u dv dx, so that's x squared, times a half x plus 1 to the minus a half, all divided by v squared, which is x plus 1. What we need to do then is show that this simplifies to the target expression. I usually find that a good move is to make the denominators the same. We have an x plus 1 here, we want a 2 and a root x plus 1. So we multiply the bottom by 2 and root x plus 1. That means we have to multiply the top by the same thing. If we multiply this by 2 root x plus 1, which remember is 2 times x plus 1 to the half, the 2 times 2 gives me 4, and x plus 1 to the half times x plus 1 to the half gives me x plus 1. Over here, 2 times a half will cancel, so I'm going to have x squared, and x plus 1 to the half times x plus 1 to the minus a half will become 1. So that's going to give me 4x squared plus 4x, take away x squared, over 2 x plus 1 root x plus 1, which is 3x squared plus 4x over 2x plus 1 root x plus 1. Then just factorizing this gives us x 3x plus 4 over 2 x plus 1 root x plus 1 as required.